Assalamu alaikum. The next concept is the gene interaction with the epistasis. So, by definition, effect of gene interaction is that one gene masks or hides the effect of the another gene at different locus. So there are two different genes which are located on a different locus, and one of them is going to affect the uh, expression of the other genes or its effect. So one that is doing that effect or because of which the other gene is not being expressed, that is the epistatic gene, and which is being suppressed, that is the hypostatic gene. Now recessive epistasis, here you can see the black and yellow crossed, and we get heterozygotes, they are black, and when we intercross, then we get uh, here the previous studied examples. So when the second allele is completely recessive, the phenotype is yellow. And both of them, the 2 and and 3 over 16 and 1 over 16 ratio is converted into 4 over 16 because we add up these two ratios and we get 4 over 16 ratio. And as this is because of the recessive gene, a recessive form of this gene, the yellow phenotype, this is called the recessive epistasis. So you can see no matter the other gene is dominant or recessive, it does not make any difference in the phenotype. The phenotype is determined by the recessive gene in recessive form. Okay. So dominant epistasis, plant with the white squash and plants with the green squash, they are crossed, and plants with the white squash. And when they are intercrossed, and we get 12 or 16. So remember in classical dihybrid cross, we get 9, 3, 3, 1. 9 over 16, 3 over 16, 3 over 16, and 1 over 16 ratio. But here we have different ratio 12 over 16, 3 over 16, 1 over 16. So that means here is something wrong. So 9 plus 3, 12. So where there is a dominant allele, so that is pulled up. So we can see ratio for the dihybrid 9331. It looks 9 plus 3 is resultant into 12, 3, 1. And that's the alternation of the middle and in case of the dominant allele. So here you can see there are two factors. The factor 1, it converts the compound A into B, and plant with the genotype small w or recessive enzyme 1, which converts compound A into compound B, and we get the white color is converted to green. But if it's dominant, then what would happen? The enzyme 1 will not work and the plant will remain green. And in this second stage, you can see if the second allele, if it's dominant, then it will convert the enzyme 2 is there, which will convert B into C, and C becomes the yellow. Right? So if it is recessive, then what would happen? It will not express and the plant will remain green. It won't be converted into. So conclusion is that genotype dominant, both of them, or first of them is dominant, do not produce enzyme 1, and both of them they are recessive, they produce the enzyme 1 but not enzyme 2, and if second one is the dominant, it will produce both the enzyme 1 and 2 and the plant will be yellow, and then this is as both of them they are dominant, so this is called the dominant interaction, dominant epistasis. A duplicate epistasis, albino cross with the albino. Here you can see gene A is completely recessive in first individual and B is completely dominant, and vice versa in the second individual, and when they are crossed we get the pigmented. And when F1 is intercrossed, and you can see where there is a recessive any one of them. That is the basically duplicate recessive epistasis. It will show albino. And only case 9 over 60, when both of them are dominant, you can see the pigmented individuals. So that is case with the snail. You can see this example. Again, compound A is converted into compound B, and then compound B is converted into compound C by using the enzyme 1 and enzyme 2 respectively. And if these both of them are completed, then we will get the colored individual. Otherwise, it will be the non-pigmented or the albino. That's the example from the snail. Thank you very much. There was another epistatic mechanisms in genetics, and this is also the deviation from